بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على رسول الله اللهم صل على محمد. Assalamu alaikum wa rahmatullahi wa barakatuh. Just to introduce myself, my name is Dr. Mohamed. I was formerly a teacher at the Kulliyyah of Pharmacy for about 10 years, from 2003 until 2013. I continued teaching at another university in Cyberjaya from 2013 until July 2020. I hope I can share with you some of the knowledge that I have gathered over the years, with the hope that it would be beneficial for your future career as nuclear pharmacist or radio pharmacist. There are many opportunities in the field of nuclear pharmacy. One, you can work as a radio pharmacist under the nuclear medicine departments in government hospitals and also private hospitals. You can also serve at the various cyclotron centers available in the Klang Valley. You may be able to apply for positions at the Malaysian Nuclear Agency and also the Atomic Energy Licensing Board. And for those of you who have interest in teaching, you may proceed for your postgraduate master's degree and to further to your PhD, inshallah, and come back as lecturers of nuclear pharmacy to be able to serve any of the pharmacy schools that are available in Malaysia. These are the learning outcomes expected from all of you. I believe, inshallah, you would be able to complete the task. For the introduction to the topic that we're going to discuss today on instruments for radiation detection and measurement, we can begin with the three main types of radiation. One is the alpha particle, second is the beta particle, and thirdly, gamma radiation. With regard to alpha particles, it is a charged particle. It is a charged particle, and it is the least penetrating of all. It can be stopped with just a piece of paper. The second particle, which is beta particles, it is also a charged particle. It travels faster than alpha particles, and it can penetrate through several millimeters of your skin. And finally, the gamma photons, it is electromagnetic radiation. It can penetrate many materials. It can be blocked with dense materials such as lead, and that's the reason why lead are being used as the main shielding material in nuclear medicine department and other places where radiation are being used. As a radiopharmacist, you need to be familiar with your task. You should be able to detect, to measure the presence of radiation, the type of radiation, the intensity of radiation, and the energy of radiation, which are emitted by various different radionuclides. And it is your responsibility to survey for the level of the radiation at your place of work. And you should also be involved in monitoring radiation exposure of your staff working in the radiopharmacy unit. And one of the rules of radiopharmacists is to dispense accurate doses of radiopharmaceuticals such as technetium-99m radiopharmaceuticals, MDP for instance, for patient use. And while working in nuclear medicine department, one of the rules is to obtain diagnostic information following the administration of the various radiopharmaceutical. Therefore, it is very important that you understand the essence of today's discussion and the various types of instruments that are being used for radiation detection and measurement. We mentioned in the previous slides, the last portion of it, there are two types of commonly used radiation detecting instruments. The first type is gas field detectors, and the second type is the scintillation detectors. So the first type, which is gas field detectors, if you look on the left side of the slide, that is the schematic of gas field detectors, which comprise of a cylindrical condenser with a central electrode known as anode, used for collecting electrons, and it has also got an outer electrode known as cathode, which is used for collecting positive ions, and it has a voltage source, and finally it has a display unit to show the quantum or quantity of radiation that is being detected. The operation of a gas field detector is based on the ionization of gas molecules by radiation, and it is followed by collection of the ion pairs, say electrons, and also the positive ions at the various electrodes under the application of voltage differential between the two electrodes. And the measured current is primarily proportional to the applied voltage, number one, and number two, to the intensity of the radiation. Remember, the measured current is primarily proportional to the applied voltage and the intensity of the radiation. Gas field detectors. There are two commonly used gas field detectors. Number one is the ionization chambers, and number two is the Geiger-Müller counters. These two devices has got two main differences based on, number one, the operating voltage. The operating voltage that is applied between the two electrodes. For ionization chambers, they are operated at 50 to 300 volts, whereas the GM counters, they are operated at 1000 volts. The second difference between the two devices, the intensity of radiation source to be measured using the unit. For ionization chambers, they are used for measuring high intensity radiation sources. Example, QT-Pi and dose calibrator. Whereas GM counters, they are used for detecting and measuring low level radiation. This is a closer picture of one of the unit, which is the QT-Pi. It is an ionization chamber, by the way, and has high sensitivity for measuring and detecting alpha and beta, and also gamma and X-ray radiation. This device is useful for measuring exposure and dose rates, for determining shielding effectiveness, for checking source containers, monitoring radiation areas, and checking results following decontamination procedures. Radioisotope calibrator is second device under under ionization chamber. Radioisotope calibrator is an essential instrument at the radiopharmacy unit of the nuclear medicine department. It is used mainly to measure, to dispense exact amount of radiopharmaceutical for patient use. For example, dispensing of technetium-99m DTPA if the request is for dispensing of 20 millicuries of technetium-99m DTPA, the radioisotope calibrator is used. And other uses are for measuring doses of iodine-131 for radiotherapy purposes. With regard to the radioisotope dose calibrator, the major components comprises of a well-type ionization chamber, of course filled with gas, because it is one of the gas-filled detectors. So the first component is a well-type ionization chamber, which is placed inside it a high pressure argon gas, and a high voltage source, second component, and the third is an amplifier or electrometer, and finally a display unit complete with the power supply. This is a typical dose calibrator schematic on the right, and an actual dose calibrator photo on the left. If you look closely to the photo on the left, you will see next or close to the dose calibrator is an arrangement of shielding materials which are made of lead. This is to prevent the disturbances that may come from stray radiation from the laboratory. This is to ensure that the reading of the dose calibrator is not influenced by background radiation that may be found in that area. So you need good shielding material, and for this purpose lead bricks are being used. And if you notice the dose calibrator, below the display unit you see several black buttons. Those are resistor selector buttons or radionuclide buttons for you to choose to select which radionuclides you are measuring. Yeah, the schematics of the dose calibrator is given on the right, and you see the vial of radiopharmaceutical is placed on a sample holder and lowered into the well chamber, and you have the electrode, collector electrode, and also the outer electrode. And outside the unit you see close to it the lead shielding and also the electrometer and the display unit.